Gracias. Okay. Thank you. My intention of the presentation today is a little bit different from the previous one. I want to give the scope of an industry. So what is behind 3D printing industry in terms of processes and in terms of basically products. So I will start from our history, and I want to show that not only new companies are linked to 3D printing. Our company is from the 50s, and we have several evolutions. During the last 50, 60 years, we came from a traditional manufacturing company to, I would say, high technology and high demanding products nowadays. So through all those years, one thing has been clear. During 60, almost 50 years, our turnover grew to a very steady pace. But specifically from 2006 to 2016, the last 10 years, the growth of the turnover has almost doubled. Okay? So this is one indicator of, I want to explain later on why it happens. So not only in terms of turnover, also in terms of employment. So we generate qualified employment. And this is why I want to focus in that period. What happened in the last 10 years in our company that produces that jump in our turnover, okay? So basically, this is the story behind, and this is what we had in products. We came from an industrial manufacturing, as I mentioned. Basically, we produce parts for the automotive industry, very precision parts for the automotive industry for almost 40 years. At some point in time, we decided also to explore the medical sector. We started for the dental products, basically dental implants. That was the beginning of our story in the medical application. But very soon we realized that there was a demand on customization. Okay? So in 2009, we started to do customized prostheses. Later on, we have a speaker that will really go in deep in that process. So I just want to go through that, mentioning that we made that step. And later on, in 2014, we start a new project that I will explain in detail based on the application of customized techniques in the whole medical aspect. So specifically, those last two things, the digital jump and the medical jump, are the explanation why we did the jump from 14 million to almost 28, okay? Why it happens. And I want to mention just very, very quick that we as an industry, we are a follower of what is going on in the industry. And the industry is following all the time what's going on in the society and vice versa. And this is a link that we all have to take into consideration. And specifically in the last, I would say, 10 years, many things from the society has impacted the industry. I would just mention, I think it's 4 slides, but some topics that for me are key topics. First of all, the level of use of mobile, okay? Is the same picture, I think is the Rome, and you can see in the 2005 that there's a couple of mobile, and in 2013, almost everyone is wearing a mobile. So something happened here in the society, and it is clear, okay? Also in the schools. What's going on in the schools? Our kids are learning with computers, and only 10 years ago, no one had a computer in our schools. So this is a trend in the society that is affecting the industry, okay? Another one is customization. Everyone now wants to have something customized. You can go internet and check if your shoes are from one color or another, and you want to be the owner of your design. This is happening every day more and more. So we have 3 trends, right? Digitalization, one side, customization, another, and another one that's why we are here, and that's what this event is crowded, which is 3D printing. Everyone can print no matter where you are based, no matter which material, and that will be the trend in the future. So those trends are okay, but then we go to the conferences, we go to see speakers, and we always see the same examples. What happened to Olivetti? Oh, very bad guys. They didn't make the reaction on time. What happened to Kodak? Also, they were bad guys. They didn't think strategically, and they lost something. What happened with the phone industry? But never we realize that in our companies, we have exactly the same problems. And we blame the others. What are you doing that you are not doing right? But what about us? And us, as Avinent, we think we did some reactions, okay? So I'm going to explain very slight two impacts that those trends in the society changes Avinent from up, down, and down, up, the whole Avinent, okay? First of all, something that is mentioned already. This is the way that most of you, when you go to the dentist and still you have to make an impression, you remember that flavor of the impression material. Very bad experience, not good. I mean, that's over. That's over. And if not is over, it will be over in 2 weeks or 1 month. Go to dentists that have digital impressions. That will create a kind of a workflow that ended in a plaster model, non-precise, non-good products. No problem. You can do that, but it's not efficient. Then Joan Golobar will explain a little bit more in that detail, okay? Now we are having devices, it's been explained before, that can capture exactly the details of your teeth, then can transfer that to a computer, have a easy STL file, and work on that easily. So no problem, that has changed our company from down up. And finally, you can see a digital impression, a 3D printing model, more accurate and optimal for your teeth. So to that respect, no problem on that side. Other things that changes dramatically in our profession. Doctors need to understand digital clearly. A surgeon before open the patient, sees what it is, and then reacts. Now we can plan in advance. And all doctors that doing surgery need to have that capabilities. So again, digital customization changes life. This is an example from a DICOM coming to a typical segmentation. You can see from the real head, you can see the 3D head, and then you can make a virtual surgery. This is a real case. That was a mandible broken for an accident, and then suddenly you can reconstruct everything. So when the doctor goes to the surgery, he knows exactly what we have to do, how, and has the products customized to fix the different details. Then I will go through a couple of more examples, more in detail examples, okay? So, and at the end, if you want, you can print and you can try before the surgery. So those two things that I mentioned changes our life in Avinent dramatically, okay? As a common thing, as a shared, I would say, a platform is the additive manufacturing. But I don't want to speak as a manufacturer of machines. I want to speak as a user of those machines. And what are the implications of using such a machines? Because it's not only the machine, it's the system that you put the machine in. And I want to talk about the system that is working for us, okay? First of all, this is not something that you can have only a machine in a table and believe that the machine will print without any problem whatever you want. This has to be inside a corporation with the right environment, with the right people, with the right technologies behind. 3D printing as a technology will be a nice technology, but will be together with other technologies. So it's not only 3D printing, it's also milling, it's also turning, together with the capability of 3D printing. So this is our facilities. You will see a video later on that shows better our facilities, okay? Not only one 3D printer. Here in that picture, I think you can see at least 4 3D printers. One for each material, one for each type of geometries. So it's not only an expert of 3D printing and that's all. You will be an expert of 3D printing in different types of 3D printing. Here we have a rapid shape, we have an object, a staticist, we have a 3D systems, and an EOS machine. So all in the right places, all in right characteristics. Then we will see a nice picture of how laser sintering and 3D printing links, okay? The people. Don't forget the people. The machine is nice. The machine will help, will make what others cannot. But the people that is linked to those machines needs to be there. Service, reaction. We talked previously that if you serve to a hospital, you cannot, as an industry, serve to a hospital a product and tell the hospital, wait for 2 months, I will deliver you the product. The patient will be not there. So you need to react in a very, very short time. And to react in a short time, you need the right people in place. So service around the machines. Biomedical engineering. Biomedical engineering. Here I claim the universities to foster that and to help the students to bring the bridge between industries and studies. We need them. Them are the key facilitator for the 3D printing, okay? And finally, and is the last but not the least, regulatory affairs. Nobody talk about this, and this is key point, regulatory affairs. If someone want to print something for medical, you cannot print from nowhere. You have to print it, and you have to have the rights for the Ministry of Spain, at least, to have your facility approved. You have to have the rights for the ISO 13485 for the processes, and you need to have the license from the Health Department of Catalan government that is giving you a license to specifically customize your products. And they follow you up. So this is a medical product. This is not only a product. This is a medical product, and this is very important. So how we as a company, we gather that, and we did a new line of products. We call it Avinent Digital Health, okay? And now I would just want to present the type of things that then you can see it in our exhibition, what we do. Basically, is a triangle. We do customize, we do digital, and we do medtech. The main change from our company is that we substitute dental for medtech. Now we open our scope, and we are, as a company, we can serve the whole medtech industry, okay? What type of products do we do? For example, basically, oncologic patients, people that lose part of their faces, and they need to replace them, the bones lost, by new structures. This is a real case. All those are real cases, and here you can see a face that, thanks to the titanium 3D printing, we can replace that and make that patient better quality of life, okay? This is another case, big tumor below the nose, and we reconstruct the whole mandible, the whole area of the nose. These all are real cases. Again, this is a case for the lower jaw, and we can print here the model, which is the white. We can print the blue, that is titanium, and we can print the brown, that is PEEK. PEEK is a new material that also is very helpful for the medical industry. So all that can help the patient to go live, okay? Guided surgery. This is what we mentioned in advance. We can do, in that case, fibula guided cutting to replace the mandible. What the doctor will do here is will use the fibula of the patient. They will cut it in specific right places and bring it to the mandible to make the patient again recover the mastication function, okay? We will see nice cases on that. This is just to cut part of the hip replacement. Again, two materials, polyamide for the guide and resin for the bone. Why we use polyamide? Because polyamide can be sterilized and no change dimensions. When you go medical, you need to sterilize because there has to be the surgery. So if you sterilize a resin, what happens? Gamincho. So it melts. It's resin, not wears temperature. So polyamide wears temperature, and this is important. Spine, again, similar. This for one column case, okay? And this is finally for craniomaxillofacial. We have a doctor later on that will explain in detail that type of cases. But this is what's happening with that kind of things. So basically, I will finish now, and then I will have a video to show. Only for two real cases. The last one was performed yesterday, and those two cases are for the hospital Vallebron, okay? So I thank also the Department of Maxillofacial Surgery in that hospital because they are real cases on patients, okay? Case one. This is a case that, as you can see, in the mandible, there is a recession of the bone. This is caused to a cancer, an oncologic effect. So we segmented. You see the red thing. That is the area that has to be subtracted. We make the guide that will see exactly where we have to cut. And then with the software, we use Materialize, we use Mimic software. We will have the two sides. You see the green and the red are parts of the fibula of the patient that will be allocated to substitute the bone lost, okay? And then we will fix them with the blue plate and we'll replace the condyle. we make a mirror effect. We take the right condyle and we replace that to the non-present one, okay? With that, you can see that this is a space that will be empty, and we put also a peak area to make exactly the geometry of the face that the patient desires, and the doctor as well. So this is exactly how we cut the fibula. We make, as we mentioned, the cutting guide for the bone. And here is the deliverables, what we do deliver to the hospital. So that will be the condyle and the plates, okay? This is the real impression of what we do. And this is finally what we have as printed titanium for delivering to the product. So this is a real case that was made, I think, a couple of months ago. And the next one, the case 2, is just performed yesterday. This is quite different and quite impressive. This is a case of the typical person that you can see on the streets, and you don't want to look at him, but you see him. That is part of the face that is with a recession, big defect, facial defect. So to avoid that, we also did the same. We cut it to make the right place for the prosthesis. And we develop a mesh, not solid, a mesh, because it's too heavy. So it's a mesh, 3D printed, you see the gray area. And then we also allocate a couple of implants, because that patient can also have teeth afterwards. You want to have the full reconstruction, also with the implants. So we put the implants on the mesh, and then we can make also the teeth on it. So this is a real case. That is exactly what happened. You see the fixations with the little screws and how it really fits. That person has never had a mandible. So we, from our libraries, we had a nice mandible from another person, and we applied to this the geometry, and we applied to that person. So this is exactly a face reconstruction. You can see the face before and the face after. So this is exactly what we produce. You can see the production of 3D printed in titanium. And this is, again, another picture. So from that, I will ask if you have the video to put to the table, okay? And when they have it, I think it's my last thing. I have only 3 minutes. And with the video, you will see exactly a summary of my presentation, but real. You see a machine working, products produced, and from that, I hope that you enjoy my presentation. Let's see if the video is okay. And okay. Okay. With that, we finish the presentation, and I would love you to also, if you want to check our products, they are in the shell, and you can just take a look. Thank you for your attention. Thank you.